like electricity and electronics, alternating current. Number 3, oscilloscopes. How to use them. This is an oscilloscope. It is one of the most useful instruments available to engineers and technicians. Oscilloscopes are used in many different industries. Here is an oscilloscope which is specifically designed to help technicians tune automotive engines. Oscilloscopes are also found in the healthcare industry. An electrocardiogram heart monitor is a specialized oscilloscope.
Perhaps the most common use for an oscilloscope is the measuring and viewing of electronic signals. This oscilloscope aids technicians in the repair and adjustment of computers, televisions, radios, and other electronic equipment. Oscilloscopes are manufactured in different sizes and shapes for different applications. Oscilloscopes range from simple student models on the left to complex microprocessor-controlled models on the right. Although oscilloscopes may look different, they are all operated in the same manner. The oscilloscope is an instrument that displays electrical signals. An oscilloscope may be compared to a multimeter measuring AC voltage. However, only the oscilloscope displays how voltage levels change over time. Therefore, the oscilloscope displays a waveform which compares voltage and time. This is the display on a dual trace oscilloscope. Dual trace refers to the oscilloscope's ability to display two waveforms at the same time.
There are 4 groups or blocks of controls that are commonly found on all dual-trace oscilloscopes. The first block is the display, probe adjust, and power group. These controls affect the overall oscilloscope operation. The second block is the vertical group. These are the controls that affect the height of the waveforms. The third block is the horizontal group. This group controls the length of the waveforms. The fourth block is the trigger group. These controls stabilize the display. Each of these controls has a specific function. Now, let's begin the turn-on procedure.
The first step is to connect the power cord, located at the rear of the unit, to an AC outlet supplying 110 to 120 volts at 60 hertz. The A and B intensity controls located in the first block adjust the brilliance of the displayed waveform. Before turning on the oscilloscope, be sure to set these controls to their minimum positions by rotating them both counterclockwise. This must be done to protect the screen from damage due to an overbright display, which may cause discoloration or burning of the screen. Next, press the power switch to the on position. The pilot lamp should light. Now wait 10 to 15 seconds for the unit to warm up. Then, rotate the A intensity control until a trace appears on the screen. Next, adjust the focus control for the sharpest trace possible. The focus should be adjusted whenever the intensity is changed.
Notice that the screen has a grid printed on it. This grid is called the graticule. The graticule consists of divisions and subdivisions which allow the user to make precise measurements. The next step is to set the horizontal position control, located in the third block, to the middle of its range. The horizontal position control adjusts the position of the trace with respect to the vertical axis. By turning the horizontal position control counterclockwise, the trace has moved to the left of the screen. Now, adjust the Channel 1 vertical position control in the second block so that the displayed trace is aligned with the center horizontal line of the graticule. The vertical position control adjusts the position of the trace with respect to the horizontal axis.
The next step is to adjust the trace rotation control, which is located in the first block. Use a small screwdriver to adjust the displayed trace to align it with the graticule's horizontal grid. Now you must calibrate the oscilloscope. First, set the horizontal mode switch in the third block to the A position. Then, set the A seconds per division selector to 0.2 milliseconds. Next, rotate the red A seconds per division variable control fully clockwise until you feel it click. Also, make sure the control is pushed into the ×1 position. The horizontal time base is now in the calibrated mode. When the variable control is pulled out, it will magnify the horizontal time base by a factor of 10. Now, each horizontal division of the graticule is defined as having a time base of 0.2 milliseconds.
To adjust the channel 1 vertical axis, or volts per division, set the vertical mode switch to the channel 1 position. Then, set the channel 1 volts per division selector to 0.2 volts. Rotate the red channel 1 volts per division variable control fully clockwise until it clicks. The vertical axis, or volts per division, is now calibrated. This defines each vertical division of the graticule as having a value of 0.2 volts. The turn-on procedure has now been completed.
A probe and cable is used to connect the oscilloscope to the desired signal in order to view waveforms. The probe has two connection points. The spring-loaded hook at the top is the input to the channel 1 vertical amplifier. Shown on the bottom is the alligator clip, which is the common or ground connection. This probe is a 10-to-1 attenuating probe. With an attenuating probe, the incoming signal will be divided by a factor of 10. An attenuating probe allows measurements of signals that have a higher voltage level than the oscilloscope could normally read. The other end of the probe cable is fitted with a BNC connector and a compensation adjustment box. The compensation adjustment allows the user to adjust the probe for proper waveform measurement.
Now, let's look at the procedure for viewing AC waveforms. First, set the vertical mode selector in the second block to the channel 1 position. Then connect the probe to the channel 1 input terminal of the oscilloscope. Turn the connector clockwise until finger tight. Now, let's go to the fourth block and set the A-source trigger switch to the internal or INT mode. This will allow the oscilloscope to synchronize with the incoming signal. If the line position were chosen, the signal would always be synchronized with the AC line frequency of 60 Hertz. The external or EXT position allows for the use of an external trigger signal. Next, set the A and B internal trigger switch to channel 1. This will allow the signal on channel 1 to synchronize the display. If the vertical mode position is selected, the display will synchronize on a combination of both channel 1 and channel 2. The channel 2 position will allow the display to synchronize only on the signal from channel 2.
Set the channel 1 input coupling switch in the second block to the AC position. This will filter out any DC components of the waveform. The ground or GND position grounds the input terminal, while the DC position directly couples the signal to the vertical amplifier without any filtering. Select automatic triggering on the A trigger button in the fourth block. The automatic mode allows the oscilloscope to trigger on waveforms of at least 20 Hertz. This mode will always display a trace. The normal mode will not display a trace if there is no signal present on the input probe. Next, the oscilloscope probe should be calibrated and tested every time the unit is turned on. This will verify that both the oscilloscope and the probe are functioning properly. To calibrate the probe, touch the spring-loaded hook to the probe adjust test point located in the first block. A square wave should be displayed. With a small screwdriver, adjust the probe compensation adjustment screw to obtain a waveform that has flat horizontal lines. The oscilloscope is now prepared to display waveforms and make accurate measurements.
Now that you know the oscilloscope and probe are functioning properly, it will be necessary to obtain an AC source. In this example, an audio generator will be used. The output leads are connected from the audio generator across a 1,000 ohm resistor to create a load. Then connect the spring-loaded hook and the alligator clip ground from the oscilloscope probe across the resistor. Now set the A seconds per division selector in the third block to the 2 milliseconds position. Set the dial on the audio generator to 60 Hertz and the frequency range switch to the ×1 position. Powering the audio generator is done by pushing the AC power switch in. Set the channel 1 volts per division selector on the oscilloscope to a position that produces a waveform that fills the screen vertically. The larger the waveform, the more accurately measurements can be made.
This completes the basic procedure for operating the oscilloscope and viewing AC waveforms. However, there are other controls that were not used in the previous example. Let's now take a look at those controls. The Beam Fine button, located in the first block, compresses the display so that it is contained within the graticule area. This helps to locate off-screen displays when working in a relatively small voltage per division range. The A trigger level control in the fourth block adjusts the synchronization point on the waveform that the sweep is triggered on. When the A trigger level control is rotated towards the plus sign, the triggering will occur more positively in amplitude on the waveform. When rotated towards the negative sign, the triggering will occur more negatively in amplitude on the waveform. Notice that the waveform on the left is more positively triggered than the one on the right. The A trigger slope button in the fourth block selects the slope of the signal that will trigger the sweep. When the button is out, the sweep will trigger on the positive going slope of the signal, shown left. When the button is pressed in, the sweep will trigger on the negative going slope of the signal, shown right.
The single sweep button, also located in the fourth block, will display only one sweep on the screen. This is useful for viewing waveforms that do not repeat, or those that cause the trigger circuitry to become unstable. The A external coupling switch allows selection of the type of external triggering. The AC position will filter out the DC component. The DC position will directly couple the input signal. The DC divided by 10 will attenuate the signal by a factor of 10. This switch works in conjunction with the external input jack. This is where the external triggering signal is connected. The bandwidth limit button in the second block will filter out all signals above 10 megahertz. This is useful for filtering high-frequency noise.
The remaining controls are for dual trace and delayed sweep operation. Delayed sweep operation is an advanced technique. The only way to master the operation of an oscilloscope is by practice. By reading the instruction manual for the oscilloscope you are using, you can learn more about the controls and their operation. In the next program, you will learn how to measure the voltage and frequency of AC waveforms with an oscilloscope.